So real quickly, before we get going, I'm going to call in two random people in here. And I'm just dying to know, there are these forms of things that we can run into that we don't say are undefined anymore. We say they are indeterminate is the new language that we're looking for. Number 13, what is one of the two indeterminate forms that we need to be prepared to see? 0 over 0. Now, normally you would say it's undefined, but we don't say it's undefined anymore. We say it's what? Indeterminate. Awesome. Number 9er, what's the other form of indeterminateness? Infinity over infinity. Those are the two forms that we should expect and anticipate will show up on the AP exam. There's a bunch of other ones, though, too, right? What are some of the other ones? Anybody? 0 times infinity is a weird one. Infinity to the infinity, I think. Did that one show up? 0 to the 0 is another weird one. Like, there's a variety of them. And the important part is to use L'Hopital, we have to be able to get it to 0 over 0 or infinity over infinity. We don't want one of those other forms. We want to get it into that nice other form. So let's jump on in. Did I not give you a C? Oh, I did. Okay. Cool. Did you guys finish these ones? So let's check them out. I know you guys had a couple minutes to try and play around with them. Always the first thing, Mickey, that we're going to try before L'Hopital or anything. Good. Direct sub. Okay. Tangent of 0 is right here, and it's 0 over 1. That's 0. And 6 times 0, this goes immediately to 0 over 0, which is kind of a bummer because it means we have to do something to it. But with old L'Hopital hanging out with us now, it's really not much of a bummer anymore because it's super simple and straightforward to deal with. How do I evaluate this limit if I get 0 over 0? What's my first step if we're going to use L'Hopital? I'm going to take the derivative. Now, we need to be very specific because if I say take the derivative, my gut says I'm going to use a quotient rule. But we're not going to quotient rule it. This is the one place where we don't. We're going to take the derivative of the top and the derivative of the bottom. So here we go. This from L'Hopital becomes the limit as x approaches 0 of, what's the derivative of tangent? Secant squared x, and the derivative of 6x? 6. And now we just try what again? We're going to try direct sub. Now, I don't know about you guys, but I really struggle to think about secant squareds. I hate secant and cotangent. I always think in sines and cosines. If you have this locked in and you already know what it is, awesome. If you don't, there's probably one more little step that you're going to take. Instead of secant squared, that's thinking about what? 1 over cos squared. Okay, and now we'll just deal with it like this. What is 1 over cos squared as x goes to 0? That's 1 over 6. And what do we get for the limit? So therefore, and we have to write this next step. We can't just say, look, this limit equals 6. You have to go that extra step and say, oh, the limit as x approaches 0 of our original thing. We have to write this, and I know it sucks, but we have to. And if we want to be real specific, we can say by L'Hopital. And we're done. Okay, Rafa, I did not get to think about your question yet. I'm terribly sorry. Rafa asked a really good question yesterday. He said, why does this work? And that's a very deep mathematical question. I don't know it off the top of my head. Whether you actually are looking for the proof or not, I kind of doubt it. But I think we should. I think it's an interesting question. I'll get the answer for you guys. I don't know it, but when you're doing homework, that's what I'll be digging around with. Okay, this one, doable? Do we need to work through it? Okay, I'm stuck already. What's the first thing I should probably try, Rye? Yeah. Unfortunately, its sine of 0 is 0 minus 0 over 0. Was a bad sign before. 0 over 0 is not bad for us anymore, though, right? Because it means we can do what? We can use L'Hopital. Random interjection. Do you guys notice the school's warmer today? You don't? Oh, man, I hope I'm not feverish. I don't know. Masks also just make it super hot. I got masks if you guys want to feel super hot, I guess. Weird. They said they were supposed to fix it. Should I shoot an email to Miss Hanish and say my room did not get warmer then? Okay, I will send an. Whose room? Fair. I know Mr. Baker's room was really cold. Yeah, it's either really hot or really cold. I don't know. Sorry, I didn't mean to interject there. But let's keep going. All right, Right off the bat, there's something that I don't want in here. Somebody said it. 2 people said it. Take that 7 and get it right out of there, right? Constant multiples, they come out. So I'll say, okay, the 7 comes out, and I'm fine with that. And then we're going to take the limit as x approaches 0, and we're going to L'Hopital this bad boy. So let's take the derivative. Fern, give me the derivative of the top. Cosine of x minus 1 all over Ms. Bacalzo, derivative of the bottom. 3x squared. Now, here I am. We have hopped on to this second step, and we're just ready to do what again? Direct sub. Abigail, what do I get when I direct sub into this again? Cosine of 0 is, are you sure? 1. So we get 1 minus 1 is 0 over 0. Bummer. But here's the good news. If we get 0 over 0 as an indeterminate form, we can just take the derivative of the top and bottom, right? So we just happen to do it again. Now, when you encounter problems like this in the future, what you might notice is I don't want to just immediately jump, and you're going to try to just immediately jump until this is not a 0 anymore. But remember, we might get something else in the numerator and just say it's undefined. So we should check each step along the way, realistically. So let's do the derivative again. I'm going to go one more time, another application of L'Hopital's rule. The 7 is still along for the ride, and we'll just use the derivative once more. What's the derivative of cosine x? So now we get negative sine x, and minus 1's derivative is 0, so it's gone, all over 6x this time. I try it one more time, and I once again get 0 over 0. Kind of a bummer, but it's not the end of the world, because as soon as we get 0 over 0 for a limit, what can we try? We'll do L'Hopital one more time. One last time. Okay, so here we go. One more application. We have the 7 times the limit as x approaches 0. Delilah, what's our numerator finally become? Negative cosine of x over, Kalisha, what's derivative of 6x? 6. And now we'll try a direct sub. I get 7 times, this one's not ugly anymore. Negative cosine of 0. Negative 1 over 6. That is not indeterminate anymore. It's negative 1/6. So therefore, our overall limit that we began with, limit as x approaches 0 of 7 of this mess. Now, I hate this part, just for the record. What is this limit in the end? Negative 7/6. And I think it's really neat that, and I don't know if really neat is really the right word or not, it's interesting to me that 0 over 0 in this case is negative 7/6, but it was 1/6 here and it was 1 here. Like, it's weird that that spits out, but that's what it means to be indeterminate, right? We just can't determine it right then and there. Okay, overall, does this make your limit stuff much easier? Oh, by a lot. By a lot. Don't use L'Hopital unless you have to, and don't use it unless you get that indeterminate form. We're going to do a couple more that I want you to struggle through, like productive struggle, I hope. I'm going to give you 2, I think, that I want you to knock out. So here we go. We'll just keep them on the same example, and we're on delta, I believe. All right. You guys need trig practice like all the time, right? Agreed. Okay. So check it out. I want you guys to evaluate for me the limit as x approaches 0 of a lovely tangent x minus the sine of x in the numerator. And we're going to divide this bad boy by x squared tangent x. Okay, I'm going to give us, I don't know if it'll take this much time, but we're going to go 5 minutes, and we're just going to see how it turns out. Also, check this out. See how it says 5 up there? And it says 10 there. If I do this, now it's a 10-minute timer. Now it's a 5-minute timer. We're going to go 5 minutes and just see how this shakes out. Productive struggle. If you need your trig cheat sheets, they're in the back of your book. Might be helpful. Might not need them, but I want to see what you guys come up with. Talk it out. Productive struggle is the goal right now. There we go. When I do the denominator again, I now have a product with a chain and another product. And it's going to get real bad real fast. Now, just in the interest of making sure we can see it, help me out with this first part. What's first d second going to wind up being? So before we jump to 2x, remember, we just keep our first, right? So x squared, and then the derivative of secant squared to be 2 secant x, and then secant x tangent x. So that's first times the derivative of the second, plus the second times the derivative of the first, which there it is. And it's just getting, that's only this part so far. And it just gets wildly out of control, right? So at this point, we legitimately should ask ourselves, is this really worth going down this road? And what does your gut say? Like, it's gotten so bad after 2 steps of this that I think it will work eventually, but we're going to have to play the trig game for like the next 30 minutes if we do this. So when we get to these points and problems, nothing that we do is going to be like ungodly, unreasonable for us, but we should always consider and just think, is there a better way? Now, we are still going to wind up L'Hopital-ing this, but this question should cross your mind if you start doing stuff that's too awful. Instead of just immediately jumping in with L'Hopital, which is a reasonable thing to do because it's worked on every other problem except this one. Trig stuff can be gross. But what's easier than dealing with tangents? Sines and cosines. If before we do anything L'Hopital related, can we try to rewrite the original? Like, let's just see what happens, because if we don't rewrite it, we wind up in this awful loop of terribleness. But maybe, just maybe, we can rewrite it first. So let's try rewriting first. Because if we can make a problem easier, well, we certainly should. Okay, if we do this here, and we're just starting back at the beginning, notice we didn't erase a bunch of stuff because I want it to be very clear that, yep, this is where we ran into trouble. Instead of tangent, what can I write? So sine x over cosine x, and that's minus sine x over, and we'll just make it, the fractions aren't going to line up nicely, but x squared times sine x over cos x. So a little bit of rewriting. And let's just see, is there anything obvious that we might choose to do here? So we could take out a sine from top and bottom and divide it out, right? So I'm concerned that we're going to goof up with the algebra if we try to do it in one big step, but I think that you're right. Anybody else concerned that you might get goofed up if you try to factor a sine out of everything here? Angel, was that a yeah? Okay, so that's what I was kind of expecting, to be honest. Can I rewrite this nicer one more time? Like, if I want to subtract these, this would be sine x cos x over cos x. Okay, so I'm just going to write this instead of a fraction over a fraction. We're going to write it a little bit nicer first to see if the algebra can get easier. So let's just see if we write this a little bit nicer. And not everybody would have to do this, but it is a good piece of advice. So the whole numerator becomes sine x minus sine x cos x. And that's all over what? Cosine x. So all that I've done here, if in case somebody's looking at it, as I just did this without physically writing it here, cosine x over cosine x. I just made a clever choice of one. So that's my whole numerator. Now, when I divide by a fraction, I'm really multiplying by the reciprocal. So this is x squared sine x, all divided by cos x down here, because these just shove right through. So I think it's times cosine x over x squared sine x. And this little step that takes me like 20 extra seconds, I think will help us to avoid a ton of the extra mistakes that one might make. When we look at it here, Bea, is there anything like obvious to you that divides out or falls out to make this nicer? The cosines, for sure. The cosines just divide right out immediately. Okay, so I'll cross those guys out. And then I'm going to use Rafa's suggestion again, because I think it's a good choice, but we can avoid the mistake. Can I now factor a sine out of top and bottom? So I will do that, and I'll rewrite it. We'll factor the sine out, and I'll actually write it, and we'll just cross them out when we get there. So let's see. If I factor a sine out of this one, we would have a sine x, and it would be times what right here? And I don't need a fraction anymore because my fraction is going to be gone. What would it leave behind? One more time, because all I heard was murmurs. Good. 1 minus cosine x. When I factor a sine out of the denominator, it would just be sine x, and I'm just going to rewrite it the different way because I'm not really factoring it, over x squared. In taking this little detour to try to clean this up, is this a much nicer problem to deal with? Can you all tell that this is a much nicer problem to work with? How many iterations of L'Hopital do you think we're going to need? 2 of them. Why 2, Fern? X squared is going to become 2x on the first iteration, and then it's going to become 2 on the second, and then I'm no longer indeterminate. I can already tell it's going to work out for me. So at this point, after rewriting it, those divide out. We should check my direct sub. What does it give me? To make sure that I can L'Hopital it. And is that L'Hopitalable? I don't know that that's a real verb, but I like it. Adjective? That'd be an adjective, right? Something that L'Hopital can be applied to. It's a descriptor of the, I don't know. I'm not grammatically great. All right, well, let's try it. Let's hop on to the next step. What's the derivative of 1 minus cos x? Sine x over 2x. And I'm going to try L'Hopital, but K-rad, what happens? Well, gosh darn it, 0 over 0. But Sean, you're going to hook it up because what do we need to do if we get 0 over 0? Let's L'Hopital one more time. And here we are, big culminating moment, I think. Derivative of sine is cosine, and the derivative of 2x. And lo and behold, this whole time, 0 over 0 has been a sneaky way for us to write what number? 1/2. And again, the tediousness, we're just going to have to really indulge it. Therefore, we don't stop here because we haven't answered the actual limit yet. We said this is the limit of this one. We need to get the original one. So I have the ability to copy and paste. Sorry that you guys don't. What? I may not have that ability. Scratch that. The limit as x approaches 0 of, lost my spot, tan x minus sine x. Is that this one? Gross. And we're done. Okay. I'm torn here if I want us to try to do another one that's not necessarily on the AP test. Should we check out one other form real quick? Good choice. I want to try one more. And we'll do this one together. I won't make you work and struggle productively on your own, but I will make us struggle productively together. Last one that we're going to do, that was delta, right? All right, so here's echo. All right, last one that we're going to do today. And then we get quite a bit of time for homework. I want us to take the limit as x approaches 0 from the right of x to the x. Well, that's pretty neat. What's the first thing I'm going to try? I'm going to try direct sub, and I don't know if I'd say the good news, but the news is that when we direct sub, what does this become? 0 to the 0. Now, that is not undefined. It's what? It is in determinate. Well, we need to be able to get it into that 0 over 0 or infinity over infinity form, right? Like that's the whole goal, to be able to L'Hopital this. But we don't have it yet. I am open to suggestions, and I think if I phrase it one way, everybody will have at least a basic idea. I need to get somehow that x out of the exponent. How can we get stuff out of exponents? Or how do you undo an exponent is another way to word that. We take the log of stuff somewhere, right? Like that's the only approach. So here's what we're going to do. We're going to make a little comment, and it's going to feel odd for a second. But let's let y be x to the x. So it's like we have some function, right? We're taking the limit of a function, and here's our function. Now that I have this written as an equality, can I take the natural log of both sides? I think so, right? So let's do that. Let's take the natural log of both sides and just see kind of if we can find a way through this. If I take the natural log of the left, I'm going to get ln y. What's the natural log of the right side of this? X ln x. Okay. Everybody on board with this still? Like we haven't done anything weird, but here's what we can start thinking about. I now know that these two are the same thing, right? Like that's what equals means. These are the exact same thing. So if I wanted to do algebra and make it feel like I'm doing it, no cheating, I think if I take the limit of the left and the limit of the right, I'm okay to do that because I'm doing the same thing to both equations. What's weird about the limit on the left side is it's still going to be the limit as x approaches 0, which is a weird idea because we have x approaches 0 of the natural log of y. And that feels wonky. However, if we just follow the algebra, if I took the limit on the left, I also just do what? Yeah, let's just do the limit on the right as well. Okay, so here we are, and we get to decide which side we want to deal with. I don't think I really want to deal with this left side. It's kind of a mess right now. But the right side's not terrible. Is this right now, if we only focus on this right side, is it indeterminate yet? Well, kind of. If we think about the graph of ln x, and I think we did this exact thing yesterday. Here's my x and y axes. Here's the graph of ln x. As I get closer to 0 from the right, what does this approach? So when we tried direct sub, which is our natural first step, we wind up with 0 times negative infinity. That is indeterminate. That's one of those forms. Is it L'Hopitalable indeterminate, though? So here's the big question. I don't remember if we did it yesterday or if we just talked about it. How do I take this limit right here and make it L'Hopitalable? I can rewrite it somehow. You may have to check your notes because I'm pretty sure we did it yesterday. Natural log of x over what? Over 1 over x. Okay, so as we do this, I take the natural log of x over 1 over x, and let's just see what shakes out. The natural log of x as I approach it is still 0 over infinity. What is that? Is that one of our indeterminate forms, or is that just a number? It's just a number, and it's just what number? It's just 0. This is not indeterminate anymore. It's just 0 at this point in time. So now that we have this, we are so close. We just found that the limit on the right side was 0, right? But we also found that the limit of ln y is also 0. How can we get our last little answer out of this? We now have, and I'm going to take us there, the limit as x approaches 0 from the right of ln y must be equal to 0. We've dealt with the right side with the understanding that the limit of the natural log of y was still on the left. Well, what's a natural log really mean? This is a logarithm with base what? So this is the limit as x approaches 0 from the right of y equals e to what power? If we use this exponential stuff, e to the 0, which is what? And look at that. We just did a super transcendental wonky function. And it's nice to see. The good news, this will not show up on the AP test. This is pretty far out there as far as abstraction goes. These functions are not of the nice flavors that we're typically used to. But it's cool to see that while you might not have discovered this, and I might not have discovered this just on my own playing around with it, like quickly anyway, we can do them. And you're not going to be asked to do exactly this, but it's cool to see that we can do these wonky things. Okay, you guys have about 20 minutes that I'm going to let you just work on stuff. So tomorrow, I guarantee I collect the assignment that I'm about to write on the board. Let's knock out homework 4.5, and we will find this on page 338. And I want you guys to work 27 through 41 odd and the odd AP problems. Cool. 4.6, we get to do some hardcore graphing. Oh, 4.7 is one of my favorite sections. And then 4.8, we'll see. Probably by the end of next week, we'll finish chapter 4. Sweet. I'm going to give you guys 20 minutes to work on stuff. I will free